anything you say can and will be used against you in the court of law.
All right, if you don't mind, take your AirPods out and log in, please. We're gonna, each slide covers a topic and then examples. Topic, examples, okay? We are looking at logarithmic functions. If you recall this from Algebra 2, I hope that if you don't like logs, I hope now you will like logs, because I hope to be able to change your mind on it. Huh?
That's not going to happen.
Okay, well, you never know. We'll see.
Oh, I'm pretty sure.
Please go to this slide. Please make the marks that you see to help draw your attention to the keywords. You need to know that what is the point of log equations? They are important because they are the inverse of exponential equations. If you have an exponential equation that you're trying to solve, you use logs because they're inverses. It's like if you have an equation with addition and you need to solve it, you use subtraction because it's the inverse. Log and exponents are inverses. That's the importance of them. How do you understand this graph right here? This graph in the gray, I know y'all's is not color coordinated, so you could just make the red maybe bold or something, I don't know.
It is bold.
Oh, okay. It is. The gray graph is an exponential growth. It's an exponential growth. And then the red graph is its inverse. The way it looks when they're on the same coordinate plane. What does the actual function look like? It would be this log right here. This graph to the right, the gray graph, is decay. And the red graph is the inverse. We've got growth, we've got decay. Yes. What's the difference between what she said? Oh, inverse is the word to describe opposite. No, exponential. The log is the inverse of the exponential function. Yeah, inverse is the relationship between them. They're opposites. They undo each other. Remember the dotted line that you see in between both of those graphs is that y equals x line of symmetry. And we talked about how that was cool because when you're working with inverse functions, you change y to x and x to y. So this is the picture of their inverse relationships. Go to this slide. Do you have a calculator?
Yes.
Okay. We are going to look at finding logarithms on the calculator. It's been a while.
Just the one
We
thing
do
on
need to
spot.
make sure your calculator is in real mode. The only reason it would not be is from that last chapter when we were working with imaginary numbers. So hit the mode button, find the word real, and please highlight it. Hit the mode button, find the word real, and highlight it.
Mode.
I'm trying to pull mine up. Hold on.
Alright, we'll do plus and I'll let one on charge.
One being the lowest. So, no, 10 being the most.
You'll notice that real is on the line with imaginary, so that's what I meant by from the last chapter. Okay, the directions say find each of the following logarithms on a calculator. Make sure you're in real mode. Round to 4 decimal places. Wait a minute. What am I Oh, there.
I don't know what's wrong.
I just realized when I turned my page, I went to the wrong. So I'm still on logs, but I was like, that does not match. It says find each of the following. Okay, so this is from Algebra 2. You with me? Let's do
Holcombe,
this.
Miss Holcombe. Garrett's calculator is in Portuguese.
All right. Please go up here to the top. You ready? Leave some space right here. Leave space here for us to write something, and then come right here. I want you to write really big. Log. Oh my gosh. Yeah, hold on. Yeah, just let. Right, log, and then we're going to put base A to the X equals Y. That is not in an exponent's position. You will never have the word log and an, well, no, wait, I can't say that.
We put the X in parentheses here.
You're not going to see it in parentheses unless there's more than one term there. So
It's just people.
understand both. It's not a multiplication. Okay, so do y'all remember sine, cosine, and tangent?
No.
Yes. So
Can you actually show us?
well, not right now, but yeah, we could do that. Sine, cosine, tangent always had an angle measure after it, and I don't know if you learned this, but they're not multiplied together. They are written side by side, but the connection is the trig function. The connection here is the logarithm. There's no multiplication happening. It's the way you read it is the log with base A of x equals y. And in fact, if you'll come right here, let's write that. Log base
Brody needs some.
A of x equals y. At the top of this paper, we're going to put your, not cheat sheet, but your reminder from Algebra 2 of how to convert from log to exponential and back. So that is the formula for log. Now I want you to draw a big double-sided arrow. If you have an equation in log form, you can rewrite it, convert it, to exponential form because they are inverses of each other. Just like if you have a square root of, we'll put 8. Cube root. Let's do cube root of 8. We just talked about how that's actually 8 to the 1/3 power, right? Okay, the same formatting of going from one form to the other to try to help you to solve it is what we're doing here. This is the log form. To convert it to exponential, I want you to write this. Write a standard A. I made it bigger because it's not this little base. To the y power equals x. You will notice what word disappeared. Log disappeared. That's because it's an exponential form. So, the relationship between the two. The base of the log is the base of the exponent, and then these two switch. I'm going to say it again. The base of the log is the base of your exponent, and these two, x and y, switch sides of the equal sign. The y pops over here, and we just said a was the base of the exponent. The y becomes the exponent, and the x goes to the right of the equal sign. Okay? All right, I want you to write that. The base of log is base of exponent. Then we're going to put comma. The others switch. The others switch. You learned this in Algebra 2. Now, how well you learned it, I don't know. How much have you used it since then? Probably not at all. So let's start simple and then let's get to college level. It says find each of the following. Notice that this is not an equation. Please start recognizing when you have an equation and you don't. There is no equal sign here. This is just a standard log. It says find it, which means we're evaluating it, okay? How do you read it? It's log base 10 of 10,000. You can go to your calculator. Do you know what the standard base in log is? 10. So you could go to your calculator and you can type, there is a log button. I gotta remember where it is. There it is. Log. You don't have to type base 10 because the log button assumes base 10. And you can type 10,000. You don't even have to close the parentheses, but you can if you want to. And you get 4. Now, let me show you, don't write anything though, let me show you why it's 4. Alright? We just evaluated a log. I'm going to read it to you in terms of an exponent. What we need to do over here is we need to say that this equals something, we don't know what it is, right? Now watch how I rewrite this. I'm using that format. You with me? What's the base of the log? 10. The other two switch, and that one's going to bump to the exponent. And then I'm going to say to myself, 10 to what power would give me 10,000? 4. So that's how I can do it in my head. So that's why the answer is 4. Yes. All right, look at the next one. It's also base 10, so you're welcome to go to the calculator, type log, what is it, 0.01, 0.01. You get -2. Now let's look at it and do it by hand to understand why we got -2. So let's say to ourselves, this equals something. Let's rewrite it. The base of the log is 10. The other two switch. So 10 to what power would give me 0.01? This is where you would need to remember the rules of exponents. If an exponent, or well, not rules of exponents, but if the 10 is shrinking down to a decimal less than 10, clearly, then that decimal is moving places. So you're just looking at how many places did it move. Well, it started here, and it went left 1, 2. And that's how you can visualize that it's a 2, or you can just calculate it in the calculator. -2, sorry. Because it went which way? It went left. If you wrote +2, it would be 10 squared, which is what? What's 10 squared? 100.
Wouldn't it be 3?
No, you're thinking of the 0 that's in front of the decimal. So if you watch 1, 2, there would be a 0 there.
Oh.
That'd be point. Yeah. Oh. All right, now look at C. C is not base 10. Right?
No.
Okay. So, can we type it in the calculator? You cannot use the log button on the calculator because it's base 10. This is base 5. So let's just practice working this in our head. So we've got, it has to equal something. So 5 to what power?
It's 3.
I do that all the time. Equals 125. 3. Good job. let's do these down here. So this is log base 9 of 3 equals what? Let's rewrite it. So that would be 9 to what power equals 3? What do you notice is happening here? It's getting smaller. It is a square root. Now, how do we represent a square root in the exponent's place? We just practiced it yesterday, remember, with the 1/2, 1/3, 2/3, rewriting it as a radical. Now you can see why that was important. If 9 is shrinking down to 3, and the only manipulation I have is an exponent, it's a rational exponent because I'm taking a root of some kind. This was supposed to be pretty on purpose so that you would know, oh, the square root of 9 is 3. So this is 1/2. If you need to see it, let me show you. 9 to the 1/2 is 3 because that is saying the square root of 9 to the first power, which is 3. Y'all try the next one. Have I said that yet? You're like 4 slides ahead of me. I'm gonna get there. Yeah. You're talking about Florida? Because Florida's not going bowling, and South Carolina's not going bowling, but Tennessee is going. How many we're gonna win? You know Georgia has yet to beat Baylor in the SEC championship.
I know, but I've never heard them call.
Yeah, and Georgia was 10-0 last time we beat them in the SEC championship.
Oh,
I didn't
I'm
know.
sorry.
Saturday,
When you play like a
I didn't know you were
D3
part of the
schedule, you can be back-to-back national
What
champions.
time do you play Saturday?
I didn't know you were part of
3:30,
Look right here.
7:30. What time do we
I
play
like that
second?
here.
When?
So I hope you tried this. Did you find it to
No,
be
8.
8. It's in Atlanta, right?
all right? Let's try
And we're
it.
gonna miss
6 to what power gives me
And
1?
we're not going to miss it.
We talked about it yesterday. Anything to the
Not that.
0
I meant
power is
Friday.
1, right?
About right.
I'm going to write it right here so you can see it. 6
Wait, no,
to
we play
0
at
power
4:30.
is 1. All right, do the last one.
Saturday.
Unless they changed it.
I just wonder.
You should be.
Did you say like almost every
Are you still talking? What'd you get?
1.
So this is 5 to what power is 5, and it would be 1. Now, you will write right here, CALC. I want you to make a note. Log button is, I've run out of room, base 10. The log button is base 10. Please don't use the log button if it is not a base 10. You should know that it is common for log base 10 problems to be written without the base 10 because it's understood. So coming back up here to 1, I'm going to draw an arrow and I'm going to write the word or, showing that it could have also been written like this, log 10,000. And you might be like, well, where's the base? It's understood 10 if it's not there, okay? However, y'all are lucky, if it's not base 10, which is really aggravating, then you will hit the math button and you will arrow up. Spelled it wrong. Oh, is that the air coming on? You will arrow up to where it says choice A, and and it says the word log, base, parentheses. And now, as you write that, I'm going to pull this up and confirm that I didn't just tell you wrong. Oh, no, wait, please, it's like,
1,000,000 degrees.
yes, my heat was just on, and I was about to suffocate.
Okay, you're responsible for this.
I got it, I promise. I will cut somebody. Yeah, I'm on the list twice now. All right.
Three strikes and you're out.
I had a what? Turn around. Oh, yeah. That's all right. My name keeps coming up a lot lately.
Can we tell if there's an intruder coming?
I know, they would like.
Whenever
Is
I
that the whole?
Were you
So
guys
we
doing
not
that?
know somebody's coming, and that's why we
Unfortunately, statistics show it's not usually an intruder.
Well, then we're leaving it. I mean, I can pull it again.
I agree. All right.
Jack's
So let's
logic is
focus on what we
great.
can control, and we can control how to change the calculator.
We can control if
for,
the door's open or not.
We can control how to change the calculator for evaluating logs that are not base 10. You're going to hit math, and remember I said you're going to arrow up. If you don't want to arrow up, you can arrow down. It'll just take you longer. Arrow up. You will see choice A says log base. The beautiful thing about this calculator is it gives it to you in math print format, which allows you to know exactly where you're typing the base. You're typing the of part. Cheating. We didn't have that. We didn't have that when I was. We had graphing calculators. I'm not that old, but we definitely did not have that feature.
Man, my master was the love on this.
So when you take, you're going to show a lot of growth now, aren't you? Remember, it's math and then arrow up, and you will see. If you forget where to find it, please learn the catalog button. Catalog is that running index of every single thing on your calculator.
Where's that at?
Second, zero.
What?
Oh my word.
Auto answer.
Second, zero is your catalog, and then you can hit the L button, and it will zoom to all the words that begin with L.
Oh, like a letter? Oh.
Find the letter L, that would be the right parentheses, and it will jump to the L section.
Wow.
You can use this on the ACT.
And we're not even. Although it does take a moment.
What is auto?
Do the mouse.
Hey, I found E.
Not if you go to like push with
Yeah, they should give us a like, what is
math.
I don't know. How do you type absolute variables on these?
Yes.
Right there.
Math.
Where?
Math.
Where it says log base.
Maybe yes. Thank you. You're welcome. Okay, so moving on though. Moving on.
Why didn't you click on it?
Did you say Miss Holcombe?
She said thank you.
Oh, you're welcome. You're welcome.
Oh yeah, sorry.
All right, so let's just go to the one that was ugly. Ugly. The one that probably took you longer, and that would be the base 9 of 3. And you will see that it does give it to you as a decimal. You would have to hit math fraction, or it's a fraction, but you should know that fraction. All right.
We can put greater than and equal to it.
Yes.
I don't know that.
Okay. Go to the next slide. Go to the next slide, please. This box right here, I would like you to label this box as special cases.
Ooh.
We already practiced them on the last slide. Please stay with me. I about said play with me. I meant stay with me. No, please and play. Please,
Fortnite.
whatever. Please stay with me. Y'all know it. Special cases. Log base A of 1 is 0 because you're saying if I take a base, A, any number, to what power would give me, in this case, the power of 0, it would always give you 1. So please remember that very simple logarithm, that if you have log base something and it says of 1 equals 0, it's a special case. So think about it in terms of an exponent. This one here is saying base A to the 1 is A. When the base and the of match, it's 1. When the base and the of part match, the answer is 1. Okay, if you look right here, this is exactly what we had on the other slide. Okay, same thing. Let's practice rewriting. We are not evaluating here. You with me? We are just rewriting it in the other format. So look at this one right here. So notice it says convert. This means do not evaluate. This is where your calculator is not helpful. We're just converting it. All right, I'll be honest with you. My whole little technique of saying the base of the log is the base of the exponent and the other two switch is only really helpful if the log is on the left and the exponent stuff is on the left. So if you look at this one right here, know how to read if it's a log or an exponential. By the way, you will see the word log. So don't get that wrong. This is an exponential, but the exponent part's on the right, and that's bothering with my OCD. So I'm going to switch this. And you probably can solve this in your head, but I want you, we're not solving. Remember, we're converting to the other form. So here we go. The base of the exponent is 2. So this is going to be log base 2. The other two switch. So I write 16 equals x. That is the log format of that equation. Now, if I was to actually solve it, it would be saying 2 to what power equals 16, but we're not solving. But that's how you would read it. All right, let's go to this one. Exponents on the left, good deal. So the base of the exponent is 10. You can write log base 10, or you could just leave it off. It's up to you. And the other two switch. All right, look at the next one. E to the t equals 70. Don't let the e throw you off. Remember we talked yesterday about how e is an exponential equation. It's a function. So this is an exponent. T is the exponent, so the base of my log will be e, right? Because the base of the exponent is e, and the other two do what? They switch. All right, that was taking exponential, going to log. Now go from log to exponential. Down here, you have log base 2 of 32 equals 5. Write it as an exponential. What would it be? Yep. 2 to the 5th power equals 32. See, logs are fun. All right, what about log base A of Q equals 8? Yep. We're not evaluating, so no, you can't solve that. We don't know what A is. We don't know what Q is. We're just practicing rewriting. All right, this last one, what am I going to say? Yeah, it's bothering me. I don't like the log on the right. It messes with my little technique. I'm going to bring this over here. And some people, it may not mess with your technique. If I've told, I told you what to do, you may be like, I got this. I don't know why she has to switch it. That's just my idiosyncrasy. That's me. I'm OCD. Don't roll your eyes. Okay. It's my little thing. Like, that's what I do. You know what I mean? Like, when I'm pumping gas, I have to end on 5 or 0. Because then I know when the meter is creeping. Y'all ever had a gas tank meter creeping on you? Do you know what that means? It's when you're done pumping gas, but the cha-ching, cha-ching, cha-ching is still running. There's one at the end of Battlefield Parkway that we call meter creeping. Oh my gosh, I thought we were going to be on the news. Brad lost it. The man was like, my meters are fine. And I was like, dude, I had just saw it. And then he's holding the gas tank. And the thing was cha-ching, cha-ching, cha-ching. It was bad. I turned it into the Department of Agriculture, who went out and did a random drop-in and found that they were meter creeping. So they had their pump shut off.
Good job, Holcombe.
But then they just sold the store to a family member, and now they're back open.
What?
So don't go there.
Yes.
It is the
Thanksgiving?
when you go down Battlefield Parkway, you turn left
tax
to go through the park.
Exemption is
Right. There's a gas station right there before the Long John Silver's that is always crowded. I don't know what they're actually selling. It cannot be seafood.
Oh, Long John Silver's?
It cannot be seafood.
So good.
It can't be those little crumbs in a box.
But anyways, it's that gas station right before that. They were meter creeping. Alright. T to the X power equals M. You should totally go, hold your phone video, and just test if they're still. I refuse to go back. It's bad.
Don't discriminate.
Alright, go to the next slide.
You can make fun of me for
No. It's illegal to meter creep.
I don't even love baseball that much. Then why do you play?
Yeah. He was
I don't
not
know why to
rational
say
that day. I know they had proof that it was meter creep.
What?
I told my husband to get in the truck.
We were gonna do it last year, but you're
Some scammers put like covers on it where it'll like get your.
Oh yes,
So
every
I
time.
don't know.
Yeah, you gotta watch
I
those.
try
videos.
to.
I do Apple
all
Pay,
the
so
time, yeah. I don't want to.
All right. Please go to this one right here, and please practice using your calculator right now. Practice using your calculator.
What?
We've already said that if it's base 10, you will not see the base. So what can you say about all three of these?
They all have base 10.
They are all base 10. So you might want to make a note that there is a 10 here, and it is understood. Since they are base 10, we can use what button? The log button.
I get an error for -3.
Why do you get an error? Okay, so you do get an error right here. Does it say error or not real?
Error.
So we just switch it to imaginary?
Yours says not real. Yeah, it says error, and then if you read it, it says not real. So come right here and let's fill this in. So this is 10 to what power would give me -3? Is there any way to take a 10, only the powers, by the way,
No.
and result in -3? To a power.
What?
To a power. So this is not possible. There's no 10 to any power that would be -3, so this is not real. This crosses into imaginary. No, not. So you would just say not real. By the way, did you get this?
Yes. What are you gonna do?
Oh!
It's Wednesday, my dudes.
That
dude's a legend.
But they're They're very, well, they're just, we won't have to spend a lot of time on slides.
Holcombe.
Well,